In this video, we're going to talk about something called relative velocity. This just tells us that the velocity that you measure for any object really depends upon the point of view. Let's try to understand this with an example. Let's say that you are standing over here on the ground. It's a beautiful day, you're enjoying the scenery, and suddenly you see a truck zooming past you extremely fast, something like this. And let's say you calculate its velocity and you find out that its velocity is, let's say the velocity of the truck turns out to be 100 kilometers per hour. Now, what you want to do is you get excited by this truck's motion, and so you decide to get into the car and start driving yourself. So what you do now is you get into the car. So let's put you inside the car. Here you are. Alright, and suppose you start driving, let's say with the velocity of, let's say your car doesn't go quite as much as this guy, but let's say it goes at 95 kilometers per hour. Now here's the question. Now that you are inside this car, suppose you again look at this truck. What will you see the velocity of the truck to be? Do you still see it to be 100? Or do you see it to be faster or slower? Think about this. I want you to pause this video for a while and think, what would you see in this situation the velocity of truck to be? Now, this could be a familiar situation for you. You may have experienced this. Let's look at things from the car's point of view. Let's see. This is what would look like once you are inside the car. All you could see is the seat of the car and the window of the car, and you could see outside that truck. The first thing I want you to note is that once you are inside this car, you don't see that car moving anymore. I mean, it might shake a little bit, but that car is not moving as seen by you. The seats, the window, if there are any passengers over there, they just stay there. And now, because of this, we can say that the speed of the car or the velocity of the car as seen from your point of view now, once you're inside the car, that velocity is 0. In other words, you are at rest. So let me write that down. You are at rest. Your car is at rest as seen by you. But instead, when you look outside, what do you see? Well, now you see the ground whizzing backwards. You know, something like this. Something like that. Right? You see the ground whizzing backwards. And let's think about this. See, as seen from the ground, the car is going forward 95 kilometers every hour. So I hope this makes sense that as seen from the car, you would now see the ground going backward at 95 kilometers per hour. The ground goes backward at 95 kilometers every hour. And we can now sort of understand what's going on over here. You see the truck is traveling on the ground 100 kilometers every hour forward, but the ground itself is going backwards 95 kilometers every hour. This is like a conveyor belt that is going backwards at an extremely high speed, and some kid is trying to run on that. I hope you see that because of this, the kid will find it extremely difficult to move forward. And the same thing is going to happen for the truck. The truck keeps struggling to go forward because the ground is constantly moving back. So the question now is, if I wait for 1 hour, how much has the truck gone forward? Well, we can calculate that. So if you wait for 1 hour, you will see that the truck has gone forward by 100 kilometers on the ground. So let's write that down. Let's use this point to measure the position of the truck. So notice that the truck would have gone forward 100 kilometers in 1 hour. So this is 100 kilometers per hour. But in that 1 hour, you would also see, because the ground is going back, you would see both the truck and the ground travel back 95 kilometers. So it comes somewhere over here, travels all the way back till here maybe. So you would see that the truck and the ground, they all go together backward till here. Let's say that's 95 kilometers per hour. And now I hope you can see that in 1 hour, effectively, the truck has only gone forward. Let's see, how much is that? I'll mark it over here. How much has the truck gone forward in 1 hour? 100 minus 95, only 5 kilometers per hour. And therefore, as seen from the car, the truck only goes forward 5 kilometers every hour. So we could now say that the velocity of the truck, when you look at it from the car, is 5 kilometers per hour forward. So let's just summarize what happened. when we look from the ground, by standing on the ground, like over here, the truck is going forward 100 kilometers per hour. But from the car, when you look at it, it's only 5 kilometers per hour. So do you see that the velocity of the truck that you measure really depends upon where you measure it from? If you're measuring it from ground, you get one value. You measure it from the car, you get another value. That's the whole idea behind relative velocity. Velocity is a relative term. All right. And one last detail I want to tell you, a technical term that, people usually use when you're talking about relative velocity is they use the word reference frame. So instead of saying that the velocity of the truck as measured by someone standing on the ground is 100 kilometers per hour, they would just say that the velocity of the truck from the ground reference frame. That's the technical term used over there. So we could say the velocity of the truck from the ground reference frame is 100 kilometers per hour. And similarly, over here, instead of saying that, the velocity of the truck from the car is, as seen from the car, is 5 kilometers per hour, they would say the velocity of the truck from the car reference frame. So we will call this as the car reference frame. I want to show you this exact situation. Take a look at this video. I shot this video from inside a car. And first of all, I don't see my car moving at all, but instead notice the whole ground is traveling backwards very fast. And now take a look at this truck. The truck is going pretty fast with respect to ground, but notice that with respect to me, it's struggling to go forward. Its velocity as seen by me is extremely slow. Can you see that? I hope this convinces you that velocity is truly a relative concept.